Okay, so I'm going to start off now looking at logs. Logs are linked to indices by this. I talk about log BAP. So log, base, answer, power. So that's your base, your answer, your power. There are 3 log rules. Log AB, if you're multiplying them, you can separate them out and add them. Log division, separate them out and subtract them, and bring the power to the front. Do you see, if you have this, log A plus B, there is nothing for that. Okay, so don't confuse that with this one. Now, what could you be asked to do in logs? You could be asked to do the log graphs. To do that, you log each side and you compare it to the equation of a straight line. You draw your graph and don't forget your labels. You find the gradient. You use your initial equation, the one that they give you in the question, sub in your gradient and any pairs of values from the table to find out the other letter. And you rewrite the initial equation using the values you've found. Now I will go through this with you when we're doing the question. And exponential equations could also be a log question. An exponential is one that has got the x as the power. Now, if you've got an exponential equation, you must only have one term in each side. Then you log each side. You bring the power to the front. That's using that rule up there. Power goes to front. Multiply out any brackets, letters to one side, numbers to the other, and solve. So 3 types of questions. One on the rules, one on the graphs, and one on the exponential. So let's see this. Your first wee one that you have is solve that equation. Now that's an exponential equation because x is the power. See that? So what you do, for an exponential equation, you must have one term in each side, and I do have one term in each side, so that's fine. Then you log each side and bring the power forward. So power forward, log. Power forward, log. Times out your bracket. Put the numbers on one side, make sure you circle it, and the letters on the other. Factorise out your x, bring this over, divide, and then put it through your calculator. Okay, that's a pretty standard question for an exponential. Question 11 is one of these graph ones. Here is the equation. So if you take that, log each side, okay. Now remember you can separate that out as log A plus log nk, then bring your k forward. And then if you rewrite that as log t and just switch these around, you can see you have an equation of a straight line. Y equals mx plus c. So in your axis, log t is the y and log n is the x. It goes along the bottom here. K is your gradient. Don't worry about y-intercept. Don't want you thinking about that. So I've got to do out my wee graph, and remember what I said? Log n along the bottom, so I'd always put that in first, and log t up the side. Okay. Then you need to do your wee table, so make sure you log everything there. Then you plot. So that's your x, sometimes it's a good idea to write up there, that's your x and that's your y. You plot those on, line of best fit. When we were looking at the equation, remember I said the gradient is k. So how do you find the gradient? It's difference in y's over difference in x's. You can pick any 2 values. Now I would tend to take them from the table rather than trying to read them with a graph. I do tend to use the first 2. Sorry, the first and the last. So this one, take away this one, and this one, take away this one. Just make sure you get the y's over the x's. Work out your gradient. So that was your gradient, which is k. So you've now got an answer for k. And what you're going to do with that answer now, put it into the initial equation, and then pick an A and a T from your initial, a T and an N from your initial table. See where they are T's and N's? That table is log T and log N, so it's no good. It's an ordinary T and an ordinary N you're looking, because you already have your K worked out. If I turn over here, I have my K, so putting it in. Choose any pair. Again, I tend to choose the first ones. Sub it in. And rearrange that to get a value for A. Now you've got A value. So you see your original equation now. You've got T equals, you know your A, the N's change, and you know your K. That's you ready to go. So I put a box around that so you can find it. Part, that was all 1 and 2. Part 2, he has 60 training runs, so n is 60. So put in there 60. And in the calculator, I would go 60, then put in that power, press the equal sign, and then times it. Part 4, be really careful about the units, okay? 3 hours and 5 minutes, whereas your initial table was in minutes. So you've got to put that into minutes first. So here's the equation. Put that in there, okay? Bring this over, divide. And you want to bring this over. The opposite of a power is the root. So it is the root. So in your calculator, use your root button to the minus 1.05. And then put in those two numbers, divide, press equals, and hopefully you get 80. Now, they like asking this question, what assumption do you have? Now, if you look at your table, okay, see the way his time is 185. See the way 185 isn't in your table, it'll be outside your table, way down here somewhere. So your assumption is that this rule holds for values outside the table. And that's the standard answer that you give there. Okay, so what have we got on the next question? This is playing around with log rules. So bring your power up. Make sure it becomes 9x squared. When you're adding, you can multiply them. So that's 9x squared times 2. Divide it by 7. And just tidying that up there. The next we want is to solve the equation. Right, we've got to tidy this up. Can you see a link between that and part 1? It's the same question. Only difference is you've got wee base 5. So log, put wee base 5 in there, put in your answer. Do you remember the BAP? Base is 5. That's it. Answer is 18x squared over 2. So log, BAP, base, answer, power. The power is 2. So that's 25. Bring that 7 across, multiply, bring the 18 across, divide, and then square root at the end. Okay. Next question. It's just a standard, exactly the same as what we did in the first one. You know, you log each side, bring the power forward, times out your bracket, letters one side, numbers the other, factorize out your x, divide. And this one here, exactly the same. Hopefully that's all okay for you in that one. Right, log rules again. So that is log A plus log B minus log C. Just as simple as that. Log 2 equals P. Right, the square root is a power of a half. So log root 8 is log 8 to the half. Bring the power to the front, so it's half log 8. 2 is my magic number. 8 is the same as 2 cubed. So write that as 2 cubed. And then do you know what you can do with that power? Bring it to the front. Don't get it mixed up with differentiation. Log rules is just bringing the power to the front. That's it. So 3 over 2. Log 2, you know what log 2 is a P. Okay, 2014, this wee one. This is an exponential equation because you've got x as a power. You've been used to seeing them having more complicated ones when there's a power over here as well. But as long as x is to the power, that means it's an exponential. So the same rules apply. So what do we do before? We logged each side. You bring the power to the front. Times out your bracket. You've only one bracket times it this time. Rearrange it. All the numbers on this side, put all the letters on that side just to give it as a positive letter. Divide. Your 3 log 3's multiply and bring over divide. And just put it through your calculator. Okay. Over the page. Oh, that's a nice wee one there. That's using your BAP. Base, 2x. Answer is 36. And power is 2. Now remember that's going to be 4x squared. Bring your 4 over. And then it's going to be the positive or negative 3. But you can't have a negative log, so we just write that as positive. If an examiner wrote plus or minus, I wouldn't worry in the slightest about it. Okay, these are my favourite ones. Write log 3, 4 equals m. Log 3, 5 equals n. Don't forget to write log 3, 3 equals 1. That's where most people will make the mistake. So always, always, always put that in. We want log 3, 20 using these magic numbers. So I'm allowed to use a 4, a 5 and a 3. Well, 20 is 5 times 4, isn't it? Just add up the separate logs. That is n, and that is m. Okay, how do I get 60? Now, there are different ways you can get this. So if you don't get it same as mine, that's fine. I just saw it as 5 times 12. And then 12 is the same as 4 times 3. Splitting them all up, and then just putting in what they mean. Okay, and a graph one now. Number 9. All right, so if you look straight in at the question, that's where I always start. Okay, log each side, separate them out, bring your power to the front, compare. So my y's are my log h's, and my x's are my log m's. So you've got to log everything in the table and do a UE table. My gradient is q. So that's me drawing it out. There's my log h along there, my log m up there. Line of best fit through the middle. I remember q is the gradient, difference in y's over difference in x's. Okay? Then what you do, go back to the first equation and put in your q, which is there. Then you choose an m and h. Remember, it's from the first table. It's not from the second table, because the second table is log m and log h. So from the first table, I always just choose the first one. So h is 20 and m is 185. So stick them in, rearrange that, that's multiply and bring over divide to get your p-value. So you rewrite your equation, m changes, p doesn't, h changes, and that was your q. So you've got it all sitting there and ready to go. Part 3, put in h to be 64 and just work it out. Part 4, could you be really careful about the units? They have half a kilo is 500 grams, so your mass is 500. Then just do your normal rearranging. And your assumption, as always, rule holds for values outside the table. Okay. We've had one like this. Okay, just a minute or two ago. Log each side. Bring your power to the front. Times out your bracket. And I brought all the letters over here to get positive and the numbers over that side. Then you get to the stage, bring it 2 across, multiply, bring this across, divide, and there you go. Part B, BAP. Base is x, answer is 5, and power is 2. So x is the square root of 5. Part C, working these out. So you write down what they give you. Log 27 is A, log 25 is B, and don't forget log 22 is 1. So log 235 is 5 times 7, so just separate and add them. 2.8 is 28 over 10. 28 is 28 is 14 times 2. 10 is 5 times 2. Oh, they cancel off to give you 14 over 5. Makes it even easier. 14 is 7 2s over 5. So it's log 27, log 22, minus log 25, and just put 3 numbers in. Okay. And we're nearly through this wee one. So we've seen this before. Log, part of front, times out, tidy up. Part B is just using your wee rules to separate out log 10, 10 plus log 10x3. That's 1. Anything which has got the base and the answer being the same, your answer is always a 1. You can put it in the calculator if you want to check it out, but it always is a 1. And bring your power to the front. Now, part 2 of this is quite cool. That is part 1. And the wee clue there was the word hence. See the way it says hence in bold? So that means you're going to be looking back to see if you can use your previous answer. So put part 1 in there. Okay? Now, if you bring that wee power up, can you see the way you've log 10 on each side? So they can cancel off. What did y to the power of a half mean? It meant the square root of y. How do you get rid of a root? You bring it to our side. Opposite a root of is a square. So it's 100x6.